Hello, this video is going to be on Algebra 2 topic M4, the power rule. I'm going to take you through the learn with an example first. So the question is asking us to simplify the expression and assuming all variables are positive. The quantity 36x to the power of 1/2. And it's asking us to write our answer in the form a or a over b divided by b, where a and b are constants or variable expressions that have no variables in common. All exponents in your answer should be positive. So let's look and see what that really means, because there's a lot of language right here. So for all non-zero real numbers, so just meaning like not zero and real numbers, so from they could include decimals, they could include fractions, but they are real numbers. And rational numbers, p and q, the following identities hold. And here are all the different identities. And these are just basically the rules of exponents, right? So we're going to look and see what are some of the rules that we need to follow. I think it's a lot easier to put this into context if we select some numbers for these. So let's go ahead and call A 4. Let's call B 5. And then let's call P and Q. Let's call those 2 and 3. Okay? So let's go ahead and let's plug these in and kind of see exactly what this is trying to say. So A, which we said in our example is 4, to the power of P, which in our example is 2, times A, 4, to the power of Q, in this case 3, would be the same as writing A to the power of P plus Q. So basically, what this tells us is that if you have the same base to the power of two different exponents, you can just add those exponents together and put them next to that one base, right? And it makes sense because you could write this 4 squared as 4 times 4. And you could write 4 cubed as 4 times 4 times 4. So really what you're just doing is you're multiplying 4 5 times. And that's what you're doing here. It's 4 to the 5th power. So that explains the first identity, where you're adding exponents. All right, let's look when you have a power to another power. Let's look here. All right, well, when you have a to the power of p, that's like 4 to the power of 2. And then all that to the power of q, in this case 3, it's saying that that's the same thing as doing a 4 to the power of 2 times 3. So when you have a power to another power, oh, sorry, that should be a 3. When you have a power to another power, you're just multiplying them. So that's the same as 4 to the 6th power, which makes sense because 4 squared to the 3rd power is like writing 4 squared 3 times, right? 4 squared times 4 squared times 4 squared. And that's going to end up having you do 4 times 4 6 times, because 2 and 2 and 2. So that's why when you have a power to another power, you just multiply those powers and you keep the same base. Let's look at the third property, AB. So let me use a different color. I already used green. All right. So AB, in our case, 4 and 5. So those are next to each other. They're being multiplied. To the power of q, which is 3 in this case, it's saying that that's the same thing as a to the power of q times b to the power of q. All right, let's think about this. 4 times 5 is 20. 20 times 20 times 20 would be 8. And then the 3 zeros, 8,000. Well, it's just saying that that's the same as 4 to the 3rd power times 5 to the 3rd power. Remember, 5 to the 3rd power would be 125. And 4 to the 3rd power, 4 times 4 is 16 times 4 is 64. And if you go ahead and you multiply these, you'll see that they're equal to this, right? It's just basically saying you can break it up. It's like you're distributing this power to both of these, 4 to the 3rd power and 5 to the 3rd power. So those are the first 3 identities. Now let's clear this, and then let's talk about the last 3 identities. All right, so this identity is telling us a to the negative q power, or let's see, we had 4, and we said this was 5, this was 2, and this was 3. That's a 2. So a to the negative q power, or 4 to the negative third power, would be equal to 1 over a to the positive q power, 4 to the third. All right, so remember, when we have a negative variable, it's just like turning it positive and taking the inverse, or putting a 1 over it. So you can rewrite this as 1 over 64. 4 to the third power is 64. Let's look at what this is saying. This is saying when you have two exponents and you're dividing them, it's really like you're subtracting them, right? When we were multiplying our exponents, it's like we were adding them here. And similarly, when we're dividing our exponents, it's like we're subtracting them. Let's show what this looks like with a real example. So 4 to the power of p to the power of 2 divided by 4a to the power of q, 3. Well, this is like saying 4 times 4 divided by 4 times 4 times 4. Right? You'll notice 2 of these 4s will cancel out because 4 divided by 4 is 1, so those will cancel. But then you'll still be left with 4 on bottom. This is equal to 1/4. And another way to write 1/4 is 4 to the negative 1 power, which is what you get when you just subtract them, right? 4 to the negative 1 power is the same as 1/4. So you can see why this holds true. You have, when you're dividing exponents and they have the same base, you can just subtract them. This one kind of became yellow. All right, and last but not least, when you have a rational expression to the power of q, you could think of that as the numerator to the power of q divided by the denominator to the power of q. So if you have a over b, 4/5 to the power of q, 2 squared, then that's the same as writing 4 squared divided by 5 squared. Okay, so it's just like you can distribute the square applies to the 4 as well as the 5, the numerator as well as the denominator. Okay, and then this is just telling you that what we saw in our last video, M1, the M1, yeah, M1. This is just showing you that the numerator becomes the power and the denominator becomes the index, right? So if you had 4 to the power of 1/3, you could rewrite that as the cube root of 4. Technically, all that would be to the power of 1, right? Okay, so let's go ahead and let's look at our example. 36x to the power of 1/2. Remember, we can apply this to both terms. And so 36 to the power of 1/2, well, that's the square root of 36, which is just 6. And then x to the power of 1/2, we can either write that as the square root of x, or we could just leave it as x to the power of 1/2. All right, so let's go ahead and practice, and let's do a few of these, okay? All right, so simplify the expression and assume all variables are positive. Now, when we're doing this, remember the power of 1/2, it's like we're distributing it to each of these. So 25 to the power of 1/2, and then s to the power of 1/2. We're just splitting them up. So what is 25 to the power of 1/2? Well, that's the same as the square root of 25, which is 5. So this is 5s to the 1/2 power. So this is 5s to the power of fraction 1/2. All right, let's think about how we can rewrite this. Remember, we can distribute this. So this is like writing out 32 to the power of 4/5, which is the index of 5. And then we're going to take our answer and we're going to put it to the 4th power, right? And then the t is going to be also to the power of 4/5. So let's see, the fifth root of 32 is 2. 2 times 2 times 2 times 2 times 2 would be 32. And then 2 to the 4th power, it would go back the other way. So that would give us 16. So this is 16t to the power of 4/5. Power of, and then you get the fraction, 4/5. You have to use both of these in conjunction with each other. Okay, this one's pretty similar. I'm going to keep going so that we can see some of the other identities. All right, here we have an exponent inside. So let's go ahead and see what we do here. So this is going to be 36 to the 1/2 power, or you could think of that as the square root of 36. And then here we're having a power to another power. Remember, when we have a power to another power, we are multiplying them. So that's like w to the 5th power, and then 5 times 1/2. When you're multiplying a whole number by a fraction, you just multiply at the top. 5 is like 5/1. So this would be equal to 6 from the 36, and then 5/2 would be the exponent for the w. So this would be 6w to the power of 5/2. All right, this one's very similar to the last one. As is this one. All right, this one looks a little trickier. Let's go ahead and do this together. So 2s to the power of 11/6 quantity to the power of -3. Okay, so let's go ahead and distribute this -3. I'll write this one in 2 colors so we can keep it straight. So this is like 2 to the -3rd power, right? And then s, see this in blue, s to the power of 11/6 times, remember it's a power to another power, so we're multiplying it by -3. So let's see, 2 to the -3rd power, that's the same as 1/2 to the +3rd power, which is just equal to 1/8. That's going to be our coefficient. It's an 8, and that's a 1. And then here, for the s value, we're going to have s to the -33/6th power, right? Now remember, when you have a negative power here, that's like putting it positive and on the bottom, right? So what we're going to do is we're going to write s. See here how we did 2 to the -3rd power? This went on the bottom and became positive. So here we're putting s on the bottom, right? And then it's becoming positive 33/6. And on top we have a 1. Let's go ahead and write this in here. So we have 1/8. And then here we have s, 1/. S to the power of 33/6. I'm not sure if it wants you to multiply these two things, but my guess is that it does. So you have 1 times 1 on top and 8 times the bottom. I would imagine that this would just be 8s, and you could take this whole thing away. Let's see if this is how it wants it written. Oh, it just wanted you to simplify it a little bit more. All right, so as you can see here, we put in 33/6, right? But it wanted it as 11/2. So if this this can be simplified, since we're asked to simplify the expression. 33 divided by 6, both of those things can be divided by 3. So you would get 33 divided by 3 is 11. 6 divided by 2 is 6 divided by 3 is 2. So that was the only mistake that we made. Everything else looks good. Okay? Let's try one more of those. This one is tough. All right. Here's a similar one. Let's go ahead and try this and make sure that we reduce. All right, so step 1 is make sure that you're using this for both terms, right? So we're going to use it first, the 2s to the 2 to the 5th power, and then the s to the negative 8 over 5th power. We're going to be multiplying that times 5, and then we'll go ahead and remember to simplify this time. So first off, what's 2 to the 5th power? Let's just do this first. 2 to the 5th power is 2 times 2 times 2 times 2, 5 times. Let's see, 4, 8, 16, 32. And then let's do, in green, s to the negative, let's see, 8 times 5 would be 40. 40 divided by 5. Well, what's 40 divided by 5? That's negative 8, right? So this is the same as s to the power of negative 8, or 1 over s to the positive 8 power, right? So since we have this times 32, let's go ahead and write it out. And I'll try and show you clearly. We have this times 1 over s to the 8th power. Notice we're multiplying a whole number by a fraction. This is like it's divided by 1, because that's the same as 32. Just multiply straight across. So on top you'll have 32, and on bottom you'll have s to the 8th power. Okay? I think it should want to like this as a fraction. 32, and s to the 8th power. All right? Here we have a negative exponent. Let's go ahead and do this one. Okay. So here we have, write your answer in the form A. Oh, sorry, same form. All right, so we have 81 to the negative 1/4 power. And then we have x to the negative 1/4 power. So let's see, 81 to the negative 1/4 is the same as 1 over 81 to the positive 1/4. And another way to write the positive 1/4 power is the 4th root of 81. What is the 4th root? What times itself 4 times gives you 81? The answer to that is 3. So this whole thing simplified just becomes 1/3. And let's simplify this in yellow. So x to the negative 1/4 is the same as 1 over x to the positive 1/4. And another way of writing x to the positive 1/4, actually, in this case, we don't have to put an index because it wants your answer with a fractional exponent. So we can just multiply this times 1 over x to the positive 1/4. On top, you'll just have 1. And on bottom, you'll have 3x to the 1/4 power. So make sure that you have your numerator and your denominator, and then if you have a fractional exponent, that you press this and this as well. All right, for purposes of time, I'm going to stop the video now. And once you get up here, if you get stuck on anything, take a picture of it, send it to me via Remind, and I should help you troubleshoot these ones, okay? All right, good luck.